Hello, everyone. We're going to go ahead and get started. So, hi, everyone. Welcome to one of the last sessions at KubeCon. So, stretch, power up. We're going to have a good time. We have a lot to get through in this SIG. So, I'm just going to go ahead and jump in and get started. Hi, my name is George. I help run community at Buoyant. We're going to have a lot of presenters in today's SIG. We're going to have Dario from Attest, Chris from SoundCloud, Zach from BigCommerce. We're going to have Thomas, our newest member at Buoyant, presenting with us today, as well as William. So we're going to have all these folks because I was thinking about what to really do with this SIG. And this is the deep dive for Linkerd. And if you look at the rest of the content that we've had throughout the conference, I think you'll get a pretty good idea of where the Linkerd project is, how people are using it in production. We've done a lot of demos. I think when you kind of look at all of the talks, which should get posted usually within about a week or so after the conference, you'll start seeing these talks. If you haven't caught them, I think there were a couple of great customer talks, both from Edward Wild at Form 3 and Israel from Molten. Oliver Beatty's talk, The Anatomy of a Production Outage. Did anybody catch that keynote? A few folks? Yeah, really great story on just transparency, chaos engineering, and sort of where Linkerd fit into the production stack and troubleshooting like a real-life production outage. If you didn't catch William Morgan's talk, getting a service mesh into production without getting fired, it's both not just an amusing talk, but I think it was also very helpful from both a cultural and a technology perspective. And then we did a couple of things, right? Franzi did a great talk looking at Conduit and Linkerd and how you use a service mesh to do troubleshooting. And then in the intro SIG yesterday, Siggy did a really good job of going through line by line and looking at config files in Linkerd, explaining everything that's happening, doing custom routing with dtabs on the fly. So if you didn't catch any of those sessions, they were all recorded. And I think they show you different parts of Linkerd, where the service mesh is going, how it's operating in production, and then where it's going with Conduit. So in thinking about what we were going to do in this session, I think we're going to try to round out that content and give you a couple of additional resources if you want to get a little more involved in both using Linkerd or the service mesh in general. So here's what we're going to do. We're going to have a couple of production user lightning talks. And so these are lightning-ish, right? Like they're not, strict format, but they're going to be a short presentation around how folks are using Linkerd in production to solve real problems. Thomas is going to walk us through a guide into participating in the community, looking at the different resources that we have, and if you want to get involved, how to make contributions, how to plug in, and how to really jumpstart your Linkerd experience. And then we're going to end with an AMA session. We're going to bring William Morgan up here, our CEO and co-founder, so that you can ask anything that's on your mind about Linkerd or the service mesh or anything at all. So we should have time to go through all of those. And with that, we're just going to jump right in to our lightning talks. So I'm going to hand it off to Dario to get us started.
Thank you very much. Hello, everybody. My name is Dario. Quick intro about me. I'm head of core engineering at Attest. I lead a team of about 7 developers, going up to 10, maybe 15 in a year time, growing very quickly, and I focus on making sure that the developers can stay focused and be as efficient as possible. I'm a Linkerd enthusiast, otherwise I wouldn't be here really, and I'm a minor contributor, more like I speak about it, and I have done some minor contributions, but I'm more like helping spreading the voice. A quick word about Attest. We provide a platform that allows any company to ask any question to anyone and receive the results in real time. This allows you to have insights on what your target audience or what your actual customers think to make decisions based on data instead of gut feeling. So we have 2 interfaces. One is for the customers to create a service and see the results, and the other one is for the respondents to answer the questions, get paid, get reports, get some nice data. So this is kind of our backends. I'm not going to drill into the front end, but we have 2 different separate APIs. One is for the maker, which is where customers make surveys. One is the taker, where respondents take the surveys. And they talk to different services. Those are private services in a private VPC. Some of them talk to a third-party system. Some of them talk to a database. And it's a pretty standard architecture. We don't use Kubernetes, we use ECS. But the way the API, the thing that I want to say about this diagram is that the way the API communicates with the services is through a load balancer, which you don't see in the diagram. So the load balancer has a nice DNS name, and that's how the API knows how to reach the service. And everything is good. One of the problems that we have is that if we kind of dissect each of those apps, we will see that there is a lot of boilerplate in there that you have to repeat for each of those services. And we use different programming languages. So sometimes we kind of forget to do that. Sometimes we do it, but we end up having a lot of code that is repeated across different services. So you have circuit breakers, trial logic, connection pools, and all that sort of stuff that you should have in a distributed system. And also you have to write code for your clients to speak to your servers. And so you controller code and your client code. So to solve the first issue, kind of Linkerd that's where it comes in. And for client to server code, if you use gRPC, it can generate that code for you, so you don't have to worry about it, and you can focus on writing business value, trying to decrease the time to market and increase the quality. Second problem is, okay, cool, so we want to do gRPC now. Turns out we can't, because AWS doesn't support HTTP2 origins. gRPC uses HTTP2 as a protocol, so it's just not possible to do it. Yes, I think the answer to that is no. So it's been a while, and they're just not doing any work on that. So yeah, that's a great thing. So this is where Linkerd comes in. That's a great title up there, and that should say something about Linkerd. The thing that I really like about Linkerd is that it focuses on doing one thing really well, and that's being a service mesh data plane. And it doesn't try to do too many things, and it recognizes that there are other tools that can do their thing well, so it would rather integrate with those services rather than do it itself. I'm not going to drill too much into this, but one thing that I want to say is that the community is really awesome. It can be a bit hard sometimes to get up to speed with Linkerd, but if you jump on the Slack channel, there's always someone there to help you, especially if you're in the right time zone. Right, so this is kind of the way it works at the moment. So we have introduced a new API that is just internal. And the fun thing about building internal stuff is that you can break things, you can try new technologies. If things go down, I don't care, it doesn't really matter, it's just internal. So there is a new API, there's a new service, D, which uses gRPC, and this is kind of how it works. This is just an illustration. Obviously, the cluster is a lot bigger than that. We have a bunch of other containers. This is a linker-to-linker configuration. So in order for two containers to talk to each other, the container goes on Linkerd on the host machine, which talks to the Linkerd on the other host machine, which talks to the actual container. So we have service discovery this way. As I said, Linkerd doesn't do it itself. We use console for that. So whenever admin API wants to speak to service D, we'll just say, hey, Linkerd, can you send this request to service D? Linkerd will go to console to see where service D is. And maybe it's got it cached, so it doesn't actually have to go to console all the time. So that's how that works. You can configure Linkerd to have circuit breakers, so you don't have to have that in your application logic. You just have Linkerd do it for you. Same for trial and deadlines, a connection pooling, so after the first request, the connection is kept open, so that the following requests will be a lot quicker. Because every single request goes through Linkerd, you can have distributed tracing. To have a better implementation of distributed tracing, you actually have to change some of the code in your application. Well, you get other things as well. For example, TLS is one of the things that I didn't list in this. But as a conclusion, that says conclusion. Conclusion. So we can now speak to gRPC services because we don't have to go through a load balancer. Actually, I missed that bit, didn't I? Sorry. This is really slow. Right, client-side load balancing. So sorry, that was actually a really important point. Whenever an API needs to talk to service D, Linkerd is actually aware of where service D is, because it will probably live in more than one instance. And so it's clever enough to send a request to the service D that has the lowest latency. So for example, if service D was in the same instance as admin API, the request would probably go to that container because the latency is very low because it's on the same host. So it does clever things like that. It also means that you don't need to use an AWS load balancer, which means you can talk to gRPC services, but also means that you don't have to pay for a load balancer, which is pretty expensive these days. So yeah, we can now speak to gRPC services. We have lower latency because we have client-side load balancers. We have connection pools by default. And we use gRPC, which is a more efficient protocol because it uses a binary protocol. We have higher resiliency because circuit breakers, because of trials and all that sort of stuff. We have lower costs because we don't have to pay for load balancers. We have easier troubleshooting because we have distributed tracing, so we can use Zipkin or Jaeger to actually see what's going on and where the problem is when there is some sort of slowness or exceptions that are not expected. But the main point that I want to make, I'm running a bit late I think, is that we have all of this stuff for free. So when we now look at our applications, what we have in there is your business logic. You don't have anything else in there. Speaking specifically about gRPC services, the client and the server are generated automatically. You don't have to have circuit breakers or anything like that in your application. You can focus on delivering value. And you have fun doing so because you don't have to worry about, oh, I wonder what's going to happen about this request because Linkerd is going to handle that for you. And it always works. It's not magic, but so yeah, that was it. If you're interested in running Linkerd on AWS ECS, I wrote a blog article about that, and yeah, we're hiring in London. Thank you very much.
Cool, thanks, Dario. And now we're going to ask Chris from SoundCloud to come up.
Hey, thanks. So I'm Chris Taylor. I work in the search team at SoundCloud. And I want to talk a little bit about how we do search, how we integrated Linkerd with that, and what the benefits for me personally were. So, quick show of hands, how many of you are familiar with SoundCloud? Oh, wow, that's quite a lot. So, don't have to spend a ton of time talking about who we are. Basically, we're probably the world's largest catalog of modern music. We're definitely the world's coolest catalog, in my opinion. So, what does search at SoundCloud look like? We allow users to search across roughly 750 million of documents. At peak, we get about 1,500 QPS, and we try to serve stuff at like under 100 milliseconds P95 latency. What did search look like until about half a year ago? So at SoundCloud, we use Elasticsearch, a whole bunch of clusters. And they're fronted, they were fronted by an API, and we had, for each Elasticsearch cluster, we had a configuration of that API in like multiple replicas, everything, like all the stateless bits are running in Kubernetes. And then these different configurations of the APIs were registered in service discovery under the same name so that requests get load balanced across them as they come in through the API gateway. The reason we have multiple clusters serving traffic is for, well, we'll get there. The reason we're having multiple clusters is that we sometimes have issues where one of the clusters slows down, goes down, gets stuck or wedged or whatever. And for us, that used to mean that, you know, if we have two clusters serving the traffic, one goes down, 50% of the requests are failing, and you know, people are unhappy. I'm unhappy because I get paged in the middle of the night, or somebody else on the team. So we wanted to fix that. Previously, the way we got around this was somebody gets paged in the middle of the night. and then they shut down the configuration of the API that was serving those 50% of the requests and scared out the other configuration to handle the load, and then traffic went the other way and everything was fine, except for the post who got paged. So we wanted to fix this. The way we did this was that we introduced Linkerd. Since this is running in Kubernetes, we deployed it as a sidecar pod. And then there's only one configuration of API that the API gateway needs to talk to, and Linkerd handles the load balancing across all the clusters that are serving the traffic. So that if something goes wrong, Linkerd notices and shifts all the rest of the traffic over to the other clusters. The effect of this is it's much quicker, and this is me at 3 a.m. So big improvement there. That's most of the content for the talk. One learning that we did have while deploying this was, how many of you attended the Linkerd intro talk yesterday about DTabs and everything? Okay, so you might have, I didn't see it myself, I have to admit, but basically DTabs offer you the possibility to specify like the source and then the targets for these evaluation rules, and then there's this AND operator, ampersand operator, that lets you spread traffic across multiple services. When we tried to do this, it didn't work out the way we expected, because this operator doesn't load balance across all, it doesn't union all the instances together and then distribute the traffic. Instead, it divides the traffic and then load balances within each of those groups. So that was a sort of unexpected effect for us. The workaround for that for us was that we basically did that approach here. So we registered all the Elasticsearch clusters under the same service discovery name, and then Linkerd was happy to do the load balancing as it should. Thank you, that's it. I wanted to give a shout out to the Linkerd maintainers. Okay, I'm now a maintainer too, but when I contributed some code, I wasn't, and it was a very welcoming experience, so thank you.
Cool, thanks, Chris. And next is Zach.
Thanks, George. Hello, everyone. My name is Zach Angelo. I'm on the platform engineering team at BigCommerce. BigCommerce is a SaaS e-commerce platform, so we help other businesses sell successfully online. Here's a couple of stats to sort of hopefully prove that we are big commerce and not small commerce. We help power quite a lot of transactions every year. We have 60,000 stores on the platform, 17 billion in GMV so far, so a lot of volume. So this is a picture that everyone in this room is probably familiar with. You've got a service running in one container that wants to talk to a service running in another container. How do you make that happen? How does the foo service find the bar service successfully? Traditionally, this is done in a sort of variety of ways. I mean, even in sort of a Kubernetes deployment without a service mesh, you're usually relying on environment variables pretty heavily, right? So you've usually got either whether you're providing the environment variables yourself or whether you're letting Kubernetes do it or some other container orchestration system do it. You've got one variable for the host, one variable for the port. If you're using something like Console that has like DNS built in, maybe you're just using Console as your DNS, you're using the Console host name to help you find the service. One of the problems that we noticed with this, or one of the things, I wouldn't say problems, but one of the things that we really wanted to make better was using environment variables couples your service to the environment itself. So we wanted to sort of like break that apart a little bit. We thought that there was sort of a better way. And so I'm going to walk you guys through some steps on how we accomplish that. Yeah, so basically the goal is we just wanted to be able to spin up a client in our service, send the traffic out of the service, and have something else in the infrastructure figure out where the traffic needed to go. So the step one, at least for us in achieving this, was we needed some consistency. And the short story is we basically use gRPC to achieve that consistency. gRPC uses generated clients, and those generated clients have gRPC service names baked into those clients. So when the request lands on the wire here, it's always going to look the same, no matter if the client is Node.js, or whether it's Scala, or whether it's Java, or whether it's C++, it's always going to look the same. Excuse me. Step 2 to achieving this is you've got to publish these gRPC service names that are baked into the client into your service discovery mechanism. So for us, that's console. And you can see right here, I know that this is like really small text, but basically what we've done is we've taken containers. So we've got sort of a list of containers that are running in our infrastructure on the left, and then the tags that are associated with those containers on the right. We've basically created a tag on each container to associate gRPC services with console services or console containers. Step 3, the traffic's got to go somewhere. So you have to submit that traffic into some sort of intelligent layer that knows how to consume those tags, it knows how to consume that information that you've provided for it. In our case, it's Linkerd. Linkerd allows you to send traffic to it, and if you have it configured correctly, it'll reach into your gRPC requests and figure out, okay, you're trying to reach this service or this method on this service. But that's not enough. We had to sort of take an additional step. There's still a gap you have to cross. Linkerd will receive the traffic, and it can identify what the destination gRPC service is, but how does it, it still doesn't have enough information to know to look at a tag or know to, it can't convert that to an IP and a port, which is ultimately what it needs to actually know where to send the traffic on your network. So you've got to do something. You've got to teach Linkerd how to acquire that information. And so in our case, well, I don't remember how many of you attended the Linkerd intro talk, but the way to describe routing information to Linkerd is using delegation tables, or DTABs for short. And basically what we do is we wrote a service that watches console. And when the console service catalog changes, the service jumps into action. And it rewrites Linkerd's DTAB in response to that change. So what we're basically doing is crawling the console service catalog, looking for any tags on each service, and then writing the DTAB out. And those DTABs look a little bit like this. So you can see on the left, we've got gRPC services, and on the right, we've got console services. And then we take this DTAB and we load it into Linkerd. And that basically allows Linkerd to associate the services that it sees coming in on the wire on the left and associate it with console services on the right. Then it can then reach out to console and say, hey, I need you to give me an IP import for these console services. And that basically completes the chain. So once it has all of this information, it can then take the gRPC request off the wire and automatically convert them into IPs and ports. And then you're at service discovery nirvana. That's it.
Thanks. Those were awesome talks. Thank you, Zach, Chris, and Dario. I think my favorite part of that was that if you just sell your soul to the service mesh, you will reach nirvana. Cool. So now we're going to ask Thomas to come up and talk to us a little bit about how to plug in and get started with the Linkerd community.
Hey there. So I think this is the hazing ritual for Buoyant. I'm the newbie, and so I get to talk about the community participation. I'm an engineer. I've got my GitHub and Twitter up there. But why don't I jump in a little bit to where I'm going to go? I'm going to be throwing links at everyone at 50 miles an hour. I put it up in Bitly. Don't try and write it down. Just use the Bitly link. But let me get started. First off, let's talk a little bit about the first steps. The Linkerd docs are great, but they're a little bit spread out. The two most important places to go look are the docs. Getting started will get you installed. For me, I actually like to play around with demo apps, though. So I've shown you the Linkerd's examples. In fact, that is the coolest demo that I've seen up there right now. This is one where it takes a slow application and shows you how Linkerd can make it faster by using the intelligent load balancing, by seeing what request times are. Highly recommended to go see how that works out. Next up, once you've gotten started, obviously you want to get and hopefully give some help. We've got Discourse, Slack, Twitter. I'm personally in Slack, helping everyone as much as I can, giving them big bear hugs. Even in this time zone, we're giving folks help, so jump in there whenever you'd like to. Once you've gotten help and you've gotten started, it's time to spend a little bit of time looking at the architecture. This was actually, as the newbie, fascinating to me. And I'll come back to the request lifecycle, which we're talking about here in a couple seconds. Once you've kind of looked at what the life of a request is, though, Finagle is the next place to go, because that's where you can get really deep on the technicalities. Because for those who don't know, Linkerd came from Finagle. Finagle came from Twitter, from all of the lessons that they learned using microservices in production. So once we've gotten through all of that, I hope everyone is ready to do some contributions. The first and maybe best place to start doing contributions is plugins. Everyone talked a little bit, those of us that were in production, about some of the little changes they needed to make. So there are 4 different types of plugins that you can do. They are identifiers, namers, interpreters, and routers. I will restrain myself from saying what all of those do outside of potentially going back here and showing that identifiers tell you where to go, dtab binds, namers resolve it, and then routers, which maybe is the coolest thing, lets you actually go and write your own protocol routing. So you don't have to just stick with HTTP and gRPC, you actually can do your own protocols as a plugin. And in fact, there's an awesome write-up on making your own plugin. These are all Java or Scala using SBT. So once you've written a plugin, the next and best step is to go do and contribute some changes. Unfortunately, our repo is not tagged for new first issues. You've seen that in a lot of other projects. But there's some really great small changes at the top. Most of the developers on the team know what easy issues are. So if you just want to write some code and get it out of the way, jump into Slack, ask us a question, we can give you a recommendation. Next up is the contribution guidelines. Pretty standard. I basically laid them out here, which is, please create an issue before you go and write some code. We'd love to help you make the issue as awesome as possible, or make the PR as awesome as possible, and getting to talk to us early is the right way to do it. Then fork the repo, and obviously create a PR. As always, try and make sure that you create the PR early and label it as a whip so that you can get some feelings for code style and the rest of that. I would strongly recommend that. So that's pretty much it. Again, here's a link to the links. Those are up in GitHub as a gist, and take a look at all of that wonderful documentation. Thank you.
Thanks, Thomas. I'm going to share the slides for this presentation afterwards. You can follow me on Twitter, gmiranda23. You'll see them posted there. One of the things that I didn't mention at the beginning of the slides, we've been doing a lot of hands-on demos inside or at the Linkerd booth on the exhibitor floor. I think the exhibitor floor is about to shut down just after this session. So if you didn't get a chance to do one of those hands-on demos, they're like 5 to 10 minute scenarios that shows you how to use Linkerd or how to use Conduit. And there's some really handy exercises in there. There's a link to those at the first slide that I had in the beginning of the presentation. And next, I want to ask William up here so that we can ask any questions that are on our mind. And William, when you come up here, I'm going to start you with the question that I keep hearing in the booth, which is, why do we have 2 service meshes? Why do we have Conduit? Why do we also have Linkerd? What does that mean for the future of Linkerd?
All right, thank you, George. Hey, everyone. So for those of you who haven't already seen me give a talk, my name is William Morgan. I'm the CEO of Buoyant. The first thing I'll say is I feel a little weird standing up here because I'm not I don't want to be the representative of the Linkerd project. Like this is a project that started with Buoyant, obviously, and that Buoyant spends a lot of time and energy on. But the goal is to kind of make this a little less dependent on us and to turn it into a real community project. So I'll stand up here and I'll give you my opinions, but this is not a a Buoyant project. This is a community project, and it has to be a community project in order for it to be successful. The thing that's really going to make Linkerd successful in the long run is going to be the size of the community around it, how many not only adopters, but how many contributors we have around it. So I want you all to feel like you own this project just as much as I do, and you can be up here just as easily as I could. And also, I haven't written a line of code, in Linkerd since 2000, I don't know, a long time ago. So, okay. So, George, to answer your question, how come we have Conduit and Linkerd? So the goal for us, and we haven't really talked too much about this, is to take all of the lessons that we've learned from Linkerd and make them in a very Kubernetes-specific way and turn them and wrap those up into Conduit. And the goal is eventually, we haven't talked a lot about this, but to turn Conduit into what's effectively Linkerd 2.0. So that, how that happens and what those details are still very much TBD, but we did learn, and we continue to learn, a whole lot of stuff with Linkerd as the service mesh expands slowly to take over the entire world. And we are all, as part of the Linkerd community, on the edge of that transformation. And we need a process by which we can turn all those lessons into a better product at every point. So that's kind of the long-winded answer. With that, let's actually do an AMA. Go ahead.
Anybody have a question? I'll bring you the mic.
Ask me the hardest question you can think of. You got me on the spot. There's no escape. Just not about DTABs.
So, what would you recommend for a big financial company to start with? Start with the Linkerd or start with the Conduit?
Yeah, that's a really great question. So it kind of depends on your time frame, right? So Linkerd today is the thing that powers Salesforce and SoundCloud and PayPal, and some very serious businesses are being built around this. It's very production tested. So if your time frame is basically immediate, then Linkerd is clearly the answer. If your time frame is kind of later on, and you're willing to spend some time in going through kind of a beta process, and you are Kubernetes, like you're really developing stuff on Kubernetes, and you don't care too much in the near term about all the things that Linkerd is very good at, and in terms of talking to ECS and talking to Nomad and Console, then Conduit is where I would start.
I think we have time for maybe one or two more questions. Anyone?
I'll also say along those lines that we're making a really concerted effort to move the development process into the open. With Linkerd, we've started to do this. We weren't very good about this early on. With Conduit, we're really making a very concerted effort to do that development, to have the issues up in GitHub, to have the roadmap out in the public, to have the design discussions on the Conduit dev mailing list. So if you're interested in participating, we would like that to happen. We have mailing lists, we have a Slack channel, we have everything up in GitHub.
Cool. I think we have time for maybe one more question. Or if not, you can come talk to us at the end of the presentation.
This is your chance for fame. Put me on the spot. All right, Chris Taylor, SoundCloud, Linkerd maintainer.
Right.
He's in the repo.
When you talk about Conduit becoming Linkerd 2.0, currently Linkerd has a much broader range of scenarios that it supports. First, Conduit is very focused on being a Kubernetes thing. Do you plan to expand the scope of Conduit? Or?
Yes.
Right.
Yeah, it'll take time, but yes, we do want to expand that. We need to focus in the short term. Right, but yes, I don't want to restrict it to anything. That's not really the goal in the long term.
Cool. Thank you.
Cool. Thank you very much. I believe that brings us to time. And so if you have any other questions, we'll hang out for a minute. Thank you.